Hello everyone, this is Lee. Today I would like to present about my research project, which is classification of the endangered panda behavior with deep learning model and also the comparison evaluation of this chosen deep learning model. Let me start with the introduction. What is red panda? Red panda are the endangered species and native of Asia. Understanding their behavior are important for conservation efforts. Therefore, the traditional methods are applied for tracking the red panda behavior currently. These methods are like conducting survey, population sampling, and GPS collar, which are implemented to the red panda. But these methods cost labor-intensive, time-consuming, and prone to the human error. Therefore, I motivate to classify their behavior, especially about eating, resting, and walking with deep learning technique so that this result work can continue and contribute to the wildlife zoo and also for the red panda conservation. Here is my research question and my objective relating with my research question are to build the classification model with pre-trained CNN model, which are the efficient and ResNet using the transfer learning, and also build the self-trained model that is building the CNN model from scratch, and I named the model as a CNN Red Panda. And then I will compare the result of the three model in terms of accuracy and efficiency. Here's about the related work. In here, I separate two parts for the related work. The first part is about the traditional method and their limitations, which are currently applying for the red panda conservation. And the second part is about the state-of-the-art method and algorithm for classification and recognition of animals and their behavior. There are two sub-sessions. The first session is about using retrained CNN model with transfer learning for the classification wildlife. And also the second part is about building the CNN model from scratch for the wildlife conservation. Let me continue about the methodology. The first part of the methodology is about data collection and reprocessing. Firstly, the data are collected from zoo photographer from Japan and also from Dublin Zoo, where I implement two cameras to record the red panda video footage. And also I got useful information and images from the red panda network so that I can create a custom dataset. After that, these collected images and video footage are analyzed and removed, those especially with low red panda and also mainly involve human in the frame. After that, the frame are extracted from the video footage and crop the extracted images to focus only on the red panda and their behavior. The final step of the processing is label the category correctly as an eating, resting, and walking. The second part is about the data transformation. The extracted and cropped image are resized into the 256 into 256 before modeling. So, in this step, data augmentation is also applied, such as rescaling, zooming randomly, flipping images, and many more data augmentation methods are also used, so that the data will be transformed into various forms, and also it can reduce the overfitting. Let me continue the methodology part. About the data modeling, the data are split into two parts as a training and validation, with 80% and 20%. For the model selection, I choose the model, the state-of-the-art EfficientNet B0 and ResNet 15, and also self-trained model from scratch as a CNN Red Panda. And all these models are applied same optimizer, learning rate, batch size, and average for the comparison purpose. For the evaluation metrics, I use the accuracy, precision, recall, and F1 score as a classification report, and also confusion metric is applied. After that, for the accuracy and loss curve, especially for the training and validation data, they are also plotted. Let me present about the next slide, which is the data architecture. For the pre-trained model, EfficientNet, Behaviours, and ResNet 50, except the last 10 layer. The initial layer of these two pre-trained models are frozen. And then the additional layer consists of global average Boolean 2D and a dense layer with 256 neural, and also L2 regularization is applied. After that, another one is the batch normalization, and there is another dropout layer to prevent overfitting. The output layer has three neurons with max activation to classify the red panda behavior as eating, resting, and walking. And another model is the CNN red panda, as it is the Saturn model, which consists of 2D convolutional layers with the filters of 32, 54, and 128, each followed by the mask pooling 2D for the feature extraction and also reduction dimension. The flattened layer, which converts the feature into 1D, one-dimensional vector, followed by the fully connected dense layer with 256 neurons and another dropout layer applied. The final layer consists of three neurons with softmax activation to differentiate the eating, resting, and walking behavior of the red panda. This is about the implementation. During the implementation, firstly, the data processing, I would like to explain the data processing detail and transformation. Using the Python script and OpenCV library, the video footages are being extracted into frame, and also at the stage, structural similarity index with a threshold of 0.97 is calculated, not to be duplicated while extracting this frame. And secondly, another Python script is applied with the regional interest slider to crop the images to focus only the behavior of the red panda. After that, these cropped and extracted images are labeled into three classes. Then the data will be split into training and validation and applying the augmentation to the validation dataset. Secondly, I would like to explain about the setting hyperparameter for all the models. I apply the same hyperparameter as an attempt optimizer with 0.00001 learning rate and also batch size as 32. Sparse categorical cross entropy is applied as a loss function, and class weight is also computed for the imbalanced red panda dataset due to the limitation of data availability. Thirdly, I would like to explain about the pre-trained CNN model achievement after training and validation. For ResNet 50, it achieved 99.27%, while the EfficientNet it obtains 98.25%. For CNN Red Panda, it achieved 91.35%. The next slide will be about the evaluation. This is about the consolidated view for the evaluation result for EfficientNet, ResNet 50, and also CNN Red Panda with their strengths and weaknesses. For ResNet 50, it achieves the best accuracy for Red Panda dataset, but is slower in training times compared to the others. For EfficientNet, it's slightly lesser accuracy than ResNet 50, but it still obtains better accuracy than self-trained model with less misclassification. CNN Red Panda, it can perform classification tasks moderately, but is not highly suitable for imbalanced dataset. This is about the conclusion, and I would like to explain that this research is comparing the CNN military and self-trained model in terms of the accuracy, efficiency for the red panda conservation. Meant that resonate with the ultrasound in terms of accuracy. So this model is developed for the environments only focus on achieving best accuracy. For the efficient review, it is in harmonic between the accuracy and efficiency, although it has the training time a bit longer than CNN Red Panda. For the CNN Red Panda model, it is the most lightweighted model among three of them. But if they need to fine-tune, if the model is chosen to utilize in real environment. And for my opinion, I would like to choose the efficient because it's balance between the accuracy and also the efficiency. So the whole research will contribute for the conservation effort for the wildlife. For the future work, I would like to apply oversampling or ensembling learning to fine-tune the efficient model. And also I will collect more data of the current behavior, red panda and other behavior as well to train the model. And I would like to develop a lightweight web application so that I can allow user to upload the red panda images to classify the behaviors. Let me demonstrate the code artifact in the Google Colab. This is about the efficient review for the data splitting and also plotting before and after augmentation. Then data augmentation, these data are applying the same with the efficient, ResNet, and self-trained model. After that, this is the model architecture of the efficient review, which I explained in the presentation slide. Let me continue about the class weight computing as well as there is the model training, and here is the accuracy and validation with their loss value as well. And this is the model accuracy curve, and also this is the model loss curve. And as per this curve, the model can learn well, and also it can have only the minor overfitting, and the loss value are gradually reducing approach by approach. So this is about the confusion matrix, and the classification report are also plotted. So in here, I try testing with the ancient image, which image is not included in my red panda dataset. So in here, it can classify well for the eating of the red panda. Another one is the ResNet 15. These data are applying the same as the efficient net, so I only want to highlight about the model architecture and also model training. And this is the model evaluation part. Similar like EfficientNet, ResNet also can perform well, and also the loss are reduced gradually as well. And in here, it shows the misclassification and classification of the red panda dataset. And here is testing with the NCMH, and it can predict well. The last one is about the self-trained model. I will skip directly to the model architecture part. This is the model architecture which I explained in the presentation, and this is my model training, and the evaluation is slightly less accurate when compared to the pre-trained model, but if they can classify and well suitable for the area and environment which has the result with a constraint. So, and I also tested with the ancient images in here, image in here. So in here I can predict well as a working. Thank you. This is all about my presentation. Thank you.